Good afternoon, class.
Good afternoon.
Around a lot of the world right now, it's winter time. It's snowing, even though it's not snowing in Hawaii. We're going to start by making snowflakes today for our math. So you're all going to start with a snowflake.
What grade are we?
Third grade. We also have, I will show you, but if you want to follow along, there's also some little instructions across the top of your page. I just have to speak loud.
Yeah, exactly.
Okay, just as we saw, now I'm lost in my place, sorry.
So
Oh, it's okay, let me just,
with the objective outcome, kind of.
oh, it's okay. So just as we saw with our snowflakes, we're gonna look and see that other shapes have symmetry as well.
Right.
So can somebody show me where a line of symmetry on a square is?
Down the middle.
What if I folded it like this?
Yeah.
Or if you hold it
You
corner.
can, yeah.
This side.
So there's one line of symmetry, and then you say corner to corner? Like this?
Yes.
So how many lines of symmetry do we have?
You can also
Two.
yeah.
The other corner to the other corner.
Yeah, from
Down
that.
like this?
Mhm.
All right.
Like the cigarettes.
That's a good wrinkle.
4 lines of symmetry?
All right, so we got that. Is that all the lines of symmetry?
No.
Oh, the other corner to corner. Good job. So a square has
6.
6.
Oh, 1, 2.
2, 3, 4, 5, 6, 7, 8.
The line of symmetry goes all the way down.
Oh.
1, 2,
So there's
3,
4.
4.
4 lines of symmetry. So
We're really off
we
there,
can
graders.
also say, sorry. You notice that all the lines of symmetry meet in the center at one point.
Yes.
And from this, we can also find out about rotational symmetry. So if we put something in the middle of that, and we rotate the item here, and we do it like this. So this is where it started here. Let's trace this so we can see. So just right there, and if I turn it one time,
2 times. 3 times.
and then back. So 4 times, it still has the same shape as the original thing, right?
Mm-hmm.
So the rotational symmetry is that you can turn the item and it will still have the same shape. If I started here and I turn it like that, is that it's
No.
not right? But if I started like this and then we turned,
Yes.
then it would be. I see a lost face. Could I help you?
No, I get it.
Okay.
Yeah. Yeah.
So it looks the same after we rotate it each time. That's how we know it has rotational symmetry. So on your papers, we have the definition of rotational symmetry. So can you help me fill in the blanks for that first one? What is rotational symmetry?
A shape has rotational symmetry when it still looks the same after rotation.
Good job. So it looks the same after rotation. So that's what rotational symmetry is. Then we also have another special term that we use when we talk about it, and that is the order of rotational symmetry. And the order of rotational symmetry is the number of positions it can, in which the object looks
Can
basically
rotate.
the same. Yeah. So the number of positions
That the object can rotate.
or turn. and
But
it
still the
looks
same.
exactly the same, yeah. So there's a blank line on there that you can fill in that one as a reminder for yourself. Does anybody need a reminder of what that
Is the number of rotations an object or a shape?
has, in which the object looks exactly the same. That's what looks the same.
The number of rotations.
A shape can make, which will still look the same. And it'll still look the same.
So a square has 4?
4.
So a square, that's what
Or
it is.
4
the square one together since we just did that. So the second row down, the first. I didn't label these. Okay, so in the first column is the number of sides.
Oh, the objects, okay.
So that's what you're going to write in the first one. I'm going to find a marker. The middle column is the number of lines of symmetry. And the last column is going to be the order of rotational symmetry. Okay, so you have those three columns. So the first column, easy. How many sides does the square have?
4.
4. And then we counted how many lines of symmetry?
4.
4. Good job. And what was the order of rotational symmetry?
4.
4. All right. So now I'm going to give you each a shape. And you can fold it and discover how many lines of symmetry it has. And what is the order of rotational symmetry as well. And then after you are done, we'll share what we find out together with the rest of us. You can also do what we did and rotate up on that. Do you want me to recut it really quick?
I can make it.
I'm looking at it as a page, yeah, that's not bad.
Do this patient.
So the first one is the number of sides. So obviously each count as a side. The middle one is the number of lines of symmetry.
What?
The one? Or the lines of symmetry was like when we folded it, and it was the same number of sides.
Okay.
Thanks for working. All right, so is everybody figuring out those lines of symmetry?
I'm trying. Get in there, get in there.
A lot of them.
Probably too much.
So are they always all the same as how many numbers of sides there are?
It looks like there's a pattern, we'll have to
Yeah.
see if that follows all the way down.
Yeah. 8, 8, 8.
All right, are we just about done with that? We'll go around, we'll start with James, since she's got the triangle, and just go down our chart, and you guys can fill in the information each student gives you as we go.
So the triangle has 3 sides, and it has 3 lines of symmetry, and the order of rotational symmetry is 3.
All right, and Carla?
This one is 5 sides, 5 number of lines in symmetry, and the order of rotational symmetry is 5.
I'm tired.
Is this accent? Is that a 6?
Yes. So, nice review of our shapes.
The number of sides is 6, the number of lines of symmetry is 6, and the order of rotational symmetry is also 6.
Good job, thank you. I'm not sure. So, 7 outside, 7 sides, 4 of the line of symmetry. Let's see. Did you get all the folds in? So if we fold, there's the one. Four. Oh, okay. I missed that.
What's that shape called?
Set.
A what?
Septum.
So there's a couple that we missed. Do you want to get
Septum.
those? Yeah.
Set.
Keep going just to each corner and see. Septum, yeah, it's like September.
Like September.
That's the ninth month, so I don't know.
Well, it's just a sound. It's just a sound.
Honestly, I've never heard that shape before.
Really?
But set means 7. In French.
Yeah, right here. Have you heard of septuplets? Seven friends.
All right, now you want to count and see if you. 7? Yes. And 7 order of rotation.
Octagon. It's like an octopus. It's got 8 tentacles. 8 sides. 8.
Yeah, go ahead and fill in for all of it. Now take your snowflake and do the same thing. How many lines of symmetry? And how many, what
This
is the order of rotation?
it's got leaves.
Yeah, wouldn't it be?
You may already have your lines of symmetry there.
Well, circles should be anyway.
But it's not completely a circle because you still have these separate
Is it
lines.
6?
1, 2.
We've got the folds from when we folded our snowflakes. You can count them going all the way across. You can always
So there's 0 sides.
0 sides. When we first started, I said, we're going to cut a 6-sided snowflake. Sometimes it's hard to see the sides. But when you look, one side is from one shape to the other.
Teacher is always right.
So if we folded
But
it,
I might
if
technically
we had
count
done
as
it like one more time this way, would that have made it 12?
well, it's then you have we fold it thirds and then half, and you're folding half and half. You should try it out and see what happens. See if it-
Well, but it's already cut.
we can do another one after.
Oh, okay.
Done with our lesson, we can try it out and see what happens. So did everybody get that for the snowflake? Or is there some information you're not sure? If you're not sure, you can always mark one place and then count from there. There's 1, right? 2, and then you get back around to your original mark.
It's so complicated.
What did you have for yours?
Oh, you're so perfect.
What did you have for yours? Did you figure out? No.
Probably just cut now.
I just didn't use any cuts. Is that how this happened? Cuts?
The more paper you cut out, the lacier it gets.
Or actually, it's on the edges.
So
I have little hearts though.
that one.
Should we count it? I should
You
be
just
practicing.
yeah, it is. So we can count it, but how many triangles do you have right there?
Oh, 1, 2, 3, 4, 5, 6.
Let me see.
Okay, so if I would have done
So even though you have 12 coming out,
triangle
you only have 6 in the middle, and so your symmetry would be. Does that make sense?
It's a 6-sided snowflake.
Now, what shape is this one?
Parallelism. Parallelogram.
Awesome.
that, there's no.
So, does this have any lines of symmetry?
Yes.
Is there?
You
1.
want to find the line of symmetry first? So there's not a line of symmetry? You don't want to try?
There's no.
Does anybody think there's a line of symmetry in the parallelogram? Or this parallelogram? Yes, you can.
No clue.
Well, no. No, there's not. There's no lines of symmetry here. Does that mean there is no order of rotation?
Yeah, because it won't be.
Actually, Yeah?
Right here,
Yeah.
we're gonna rotate.
Oh, yeah.
90. Put right there.
Yeah.
Is that
Yeah.
the same as what it was?
Yeah.
Should we draw an outline?
Yes.
Let's draw an outline of it.
Look the magic.
So you got it right there, then we rotate it. No, right?
So just go one.
Well, when we get back to here, that would be 2.
Oh.
So the first one's the original,
Oh, the original
One.
is this one.
go back
Yeah.
down, so 2. So a parallelogram has 2,
Where are
but
they?
no lines of symmetry. No lines of symmetry, but it has an order of
Oh,
rotational symmetry that is
2.
2. So that is
So 0 and 4. 4, 0, 2.
on the back side, we are going to practice. There are 6 shapes that you can find around you. On the first line, you're going to write if it has rotational symmetry or not. The second line, you're going to write what is the order of rotational symmetry. And if you're very speedy and quick and this is too easy for you, then there's a little bit of questions at the bottom.
Yeah, so, right, yes or no?
So you, number of sides,
No one.
rotation.
The first one
I would
is
love one.
yes or no, if it has rotational symmetry.
Oh, this one.
Yes or no? That's the top line. The second line is the order of rotational symmetry. I'll just take 1 minute to finish that up because you guys are so good at this already and then you can figure it out.
So it's a 6-sided watch. It's like this now. Oh.
If the clock is confusing because of the hands, you can just pretend like the hands are not there. Or if you want to do it with the hands and taking that into consideration, you can. So either way, you could actually have 2 answers depending on which way you want to do it. I already told you, do you know? Do you find it easier when you have something to hold on to manipulate
Yeah,
than when you're just looking at the,
true.
try to rotate it in your mind, or
It's a headache.
you can even rotate your paper around if you need to.
It's a little late.
What's the other?
It's okay.
I feel.
All right, are we just all about done? Yes. I'm gonna collect those and I will check them and then I'll pass them back out to you so that you can take home the instructions for your snowflake and you can also remember this for future reference. And as you go home today, if you're outside or in your house, look for objects that have rotational symmetry. See where you can find them. See if you find more in nature or if you find more man-made ones. And you can also consider what is the rotational symmetry, the order of rotational symmetry of a circle.